So I'm using my mic. You can, I think you should mute yours because we won't be standing. Are you joined in? So I'm using my mic. You can, I think you should mute yours because we won't be standing. If I close this, are you still be joined in? Yes. So, okay, right now. Hello, hello.
I don't think it's that immediate.
Yeah, you hear the
Hello, 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 hello. One.
Hello. Hello.
Probably because this is good. So like
Yeah, this is fine.
the by default is not HD, but to make it HD, the by default. So I'm
So for those people who are logged in online, we are waiting for a few more people to register. Probably you might want to come back and check in about 5-10 minutes. I think we'll get started.
What I was thinking is, you could have logged in with are you logged in with those credentials that I think?
Yeah.
Oh, great.
again.
Let's move on. Okay, I think everybody can hear me okay. My name is Setu, and this is.
I'm Bhavi. Hi.
And we would like to take you through 2 hours worth of continuous integration and continuous delivery. Bear with us. If there's anything that you want to stop and you're getting lost where you want us to stop, let us know to stop, and we'll explain on that point before we actually move on. We have a live stream link as well, and we're still waiting for a few more people, but I think we can actually get started now that we have so many people here.
Share the live stream link to the next.
Sure.
Tweet of the handle.
She'll do that.
Tweet of the handle.
Okay, so shall we get started? Everybody's okay? Okay, so just like how the packet says, great software is useless if it is not delivered, onto the hands of the users, right? So we need to look at how we are deploying it, what sort of value we are able to give to our customers day in and day out. So before we actually go into what is CI and what is CD, I want to walk you through a story. And that's basically what we want to start you all off on. So that you all can identify, and I'm pretty sure this sort of a scenario must be happening in a lot of your daily life situations as well. I think a couple of years back, there was this project that I was on, and we had a development team, and we had a completely separate DevOps team. The development team was here in Bangalore, the DevOps team was in Austin in the US. And we used to, develop, we used to make sure that we tested and all of that. And then there was this separate DevOps team. We would get one person from the DevOps team assigned to us on the day of the deployment. And what we used to do is, in order to communicate with that DevOps person, we used to create a Jira ticket. And the Jira ticket had manual instructions from 1 to 10. And it would be something very similar to that. Copy this jar from this repository and place it in this location. Copy the properties file from this Git commit or from this other repository and place it into this other location. Then, start up the service with the jar command. Or even before that, there might be DB sequels that have to be executed. And this DevOps person, this poor DevOps person, has to work through this to do this. And he has to do that on the night of the deployment, and he has to do it properly. And you know the rest of the story, right? There were lots of issues. And it used to be because either we didn't write the instructions properly, we missed something, and the service wouldn't start up, or the service started up with the incorrect information, or the DevOps person would mess up and not execute, a DB migration and start up the script, and things would start failing. So then, in order to fix that, we had to improve our processes, right? So what we did was we started QAing these tickets and make sure that the QA on the team is across what the DevOps requires. And in that way, we were able to reduce the number of incidents that happen in production. But again, there were issues because still there's lots of room for human error. Next, we had compounded issues when we had orchestrated requirements. So we were working with a client who had development teams across the globe. So we were working with the Austin team. We were also working with the team here in Bangalore, and there was one team in Rio. And all of the three teams sometimes had to do deployments on the same night because they were working on services that were independent. So one had to be deployed first, then the other, then the other. So in order to help orchestrate this, we had 3 levels of managers. And they would, be on this chat channel, and they would say, okay, now Austin, you go. Fine, now you've done your deployment, now sanity check it. Now Bangalore, you go. And that way they used to coordinate these deployments across geographic locations. Again, there were lots of issues, right? Because you have the entire world on the chat channel now, right? So if you mess up, it's very public. Everybody knows it, right? So this sort of situation you put yourself in makes everybody in the company nervous. Nobody wants to mess up because if the first person messes up, everybody down the chain, suffers. So it's a very kind of a tense situation, and more often than not, it happens after 8 o'clock time or time. And you stay the whole night in order to get these deployments done. You're not thinking straight, just stressed out, and more issues land up hitting production. So this is something that happened to a project that I was working on, and by the nods that I'm getting, I'm pretty sure this is happening in a lot of places in where you work as well. So that comes to how do we go about fixing this, right? And what can we actually do to be better? First of all, we need to look at everybody in the company, right from the software development team, to the sales people, to your product owners, to your UX designers, to the CEO of the company, has got just one end goal: to deliver value quickly to your customer and deliver the right value quickly to your customer, get quick feedback so that they can understand whether they're doing the right thing. That's the end goal, right? So that's the end goal. Deliver value sooner, deliver good quality software, and in the end, invest time on the right things. You don't want to be investing time in mundane production deployments and fixing production issues when you can be working on the next big feature out there, right? So if that's your end goal, what should you be doing down the line in order to support that? That's the whole talk. That's the whole session, right? So you start off with your deployment. Automate everything. There shouldn't be anything manual. And once you automate it to that level, you should be able to click a button and your software gets deployed. That is the level of automation we're talking about. Automate everything, put everything in source repos, and on click of a button, you have your software deployed into production. You need to deploy often. So if you deploy it once in 3 months, once in 6 months, once in a year, you don't know what you're doing throughout the year is ultimately going to deliver the same value that you imagined it to be earlier on. And the issues that would happen once you deploy every 3 months is a lot more than what issues could actually happen if you frequently deploy, let's say after every application, every 2 weeks, every 3 weeks. New code is in production. And the more often that we do this, the sooner you catch these mistakes that actually happen, and the sooner you can go about fixing them. So you need to do this more often, and in order to get good, quick feedback from your client as well. And if you're deploying sooner, and if you're deploying often, then obviously you can't have zero downtime, because you can't have your client saying, okay, every 2 weeks, I'll wait for 2 hours when the system is going to be down for it to get upgraded. That doesn't work. So you need to make sure that you're doing it at zero downtime. So if you need to deploy in that fashion, what do you need to do downstream in order to support that? You need to look at your testing. You need to see how you can automate your testing to make sure that you're able to deploy in an automated fashion. What are the testing strategies you're going to use? What sort of acceptance tests you're going to write? What sort of unit tests you're going to write? You need to look at that testing pyramid, which we talk about, and look at what and where you need to write your tests in order to ensure you're delivering good quality software. You also need to be looking at testing non-functional requirements if they matter to you. If that, for example, if the performance of an application has to be tested, you need to be able to automate that. You need to be able to code it in, and you need to be able to run it every time there is a commit. That's the level of automation that you need in order to support automated requirements. If you need to do these sort of strategies towards testing, what do you need to do further down the line in order to help testing, in order to help easy deployments? You need to look at your development practices. You need to look at how you're continuously integrating CI. And we'll talk about CI quite a bit down the line. CI doesn't stop with just running a Jenkins server and building a code. That is not CI. There's a lot more involved, and we take a look at what it is. Some things that can help supplement your development practices is TDD and other extreme programming techniques such as pair programming. We'll quickly touch upon this as well. And you'll have to look at third automation. You'll have to look at how to get feedback at every point down this line quickly, effectively, so that you can deal with it, fix it, and move on. Right? So that's our agenda. We're going to be looking at development practices. First, we're going to then move on to testing strategies. And then we're going to look at deployments and how we're going to automate it. All to realize our end goal, which is deliver value sooner to our clients. Right. So let's move on to development. Any questions here? So, can anybody tell me what this is? I heard Git flow somewhere. This is the typical Git flow, branching methodology. I think it was popularized by Atlassian quite a bit. And the way it works is, I have a point. Okay, so the way it works is you have a develop branch on which you keep working. And every time you need to actually start off on a feature, you branch off from your development branch and you create a feature branch. And a new feature would again start on another branch. So you're branching for every feature, every bug. And why do you do that? To make sure that you have the opportunity to work on that feature branch in a very nice manner, to make sure you test everything and everything's working fine. And then you merge it back into develop. So you're not polluting develop with any sort of incorrect commits or incorrect things that you don't want to push out to production. And then from develop, you then push on to a release branch. And from release, you push up to a master branch. And from the master branch, you release it to production. That's the whole idea about Git flow. But there are issues here. And instead of talking about these issues, I want to demonstrate them to you. And I'm hoping you can follow me. Okay, so we're on this branch, right? And the branch is on master. So I haven't created a develop branch. I basically created a master branch from which we'll actually be working off. And it's a typical Spring Boot application. And it has an employee controller. And you get employees. And it just returns a list of employees. That's it. Doesn't do anything more than that. And your employees basically just name and age, right? So it just returns back a JSON with a list of employees with name and ages returned back. See, it's a simplistic problem. It's not probably your real life situation, but it suffices to demonstrate the point. Right now, you've got a new feature that you need to work with. Your product owner has gotten back saying you need to develop this feature. And the feature is basically including a department on the employee. And you need to return department information on the employee record for every employee record and return that back, right? So based on the Git flow technique, what you would rather do is, I've done all of the coding. Okay, so I'm not going to code here. So I'm going to check out my feature, and it's on this branch called test employee department feature. And all I've done is on the employee class, I've added a department record. And the department is basically over here. And I've created a name, right? And on the employee controller, all I'm doing is I'm calling create employee method as such, which just sets the department. A very simplistic use case. Now, when you actually run the server and you return your data back, you're going to get a department object back as well, right? But unknown to you, or even known to you, your product owner has gotten in touch with another person and they've been asked to work on another feature, which is basically expanding that department. So they've been asked to create a UI that basically shows the department's name, the number of employees on the department, a code, and whatever the department is basically. So they are working on their own branch. And That branch is over here. It's called test department feature. And what they've done is they've created the same department object, and it doesn't have a name. It has a name, but it also has a division and a code, right? Because they need more information, and they've gone ahead and created a department controller, which basically returns back a list of departments, right? So now I think you know where this is going, right? So I'm going to go on to master, and I'm going to say git merge my employee feature first. So that will basically get merged, no issues. So now my master branch has my employee feature on there. And then the department feature implementing people will try to merge their feature. Are you all following? Okay. So they're going to try and merge their branch, and that's when all hell will break loose. So you'll obviously get a merge conflict, right? Because you've got a department object, and the same department object exists in both places. So you'll try to resolve that, and when you try and resolve that, this is what you'll get. So this is a very simplistic case, I agree. But imagine if these branches existed for about 2 or 3 days, and you had a major refactoring done on one of these branches. When you try and merge it back, you're going to get a shitload of conflicts, right? And they might range from anywhere from 40 to 50 in number. And conveniently at that point, the person who actually did the refactoring is on leave. So you have no person to speak to. You have only the code and a whole bunch of conflicts that you need to fix on the manual production deployment. This has happened a lot of times for me. I face this quite a bit. And it gets in the way of actually you being productive. It's not just that. So when you actually work off branches in this manner, you would also find that some branches are dependent on each other. You'd start work on one branch, and then another person is waiting for your changes, but those changes are not forthcoming because you're still working on that branch, and you're still expanding it. You'll be working on that branch for 2 or 3 days, and the other person will be stuck for 2 or 3 days to get those changes. So you're just basically killing the productivity of the team by branching. You're not continuously integrating with each other's work. That is what CI is all about. You need to be able to, at the end of the day, you should be able to commit and push your code so that the next day when people come in, they should be able to see all of the changes well ahead of time. Right? So then the next question is, how do we do this? Right? So instead of having so many branches, the idea is to have a single branch with commits on that branch and tag points on that branch for whenever you make a release in production. That's it. It looks so much more cleaner, doesn't it? You don't have to sit and explain your branching technology, methodology or anything to new people that are actually coming in. You're saying that there's only one branch, and whatever commit you make to that branch has to be done properly, because any commit at this point can get released into production. That's the way you need to think about it. So then the next question will be, how will I be able to, work on one branch, but at the same time ensure that, my half-done feature is not going to get released? How do I put a stop there? I can't release half-baked code into production, so I won't commit. I just hold that commit in my local for a very long time, and then 2 or 3 days later, I'll probably push it in. That's what I think you might be, pushing towards if you're forced to use a single branch. But there is another way. And the other way is called feature toggles. Have you ever heard of feature toggles? Okay, so feature toggling is basically saying, I will toggle this new piece of code off, and I won't, push it. I won't push it in with that code executed. Let me give you an example. So let's say you're working on a web application, right? And on the web application, you're introducing a new button. And the button is basically making a call to a whole new API, which is retrieving stuff and it's going to put you onto a whole new street. That's your workflow. So your feature toggle there is hiding that button until your feature is complete. Once your feature is complete, make that button visible, push your code in, everything will work. When you're working on your local development branch, you can show up that button and keep working on it. So it's just a simple Boolean. If true, show. If false, don't show. And that's what you actually check in. When you check in, you make sure it's false so that it doesn't break anybody else's code path. You're free to work in the length and breadth of your code because that entry point into that new code has been toggled off. That's a simple case. In this case, how do you do it? So let me show you how you can do this. Sorry. So I'm going to revert this. And let me show you what it looks like on another branch.
Can you see the screen?
You can see.
Okay.
Okay. So this is how you would, rather introduce a feature toggle. So let's say you're working on that employee back again, right? And you have this department, and you need to, code in your department. Now your UI can deal with an additional department key that's coming back in your JSON. It'll just ignore it. If you don't consume it, it'll just ignore it. That's fine. But since you haven't finished it, there are two options available to you. One is a very simple Boolean. If true, then I will set my department. And this is how you will code in your local development environment. Everything will work as it is. Just remember to change that to false when you push it in so that you don't break anything else. That's the feature toggle, the simplistic feature toggle. If you want to be a little more sophisticated, you can try putting in a feature toggle class like this, which is nothing but an enum and with an associated value, whether it's true or false. In your local environment, it would be true, and you're testing. You have a function like this that accepts a closure, and if it is on, only then the closure will be called. Otherwise, the closure will not be called. It's basically the same if-else done in a more sophisticated way. On the UI, if you're doing stuff on the UI, you can very easily set a cookie. And at runtime, on the deployed code, you can enable stuff that you've toggled off in your code. Set the cookie, reload your web page, and whatever you have hidden will magically appear again, as long as you're toggling it. Obviously, you wouldn't want this code to seep into production, so you'd have another flag saying if it is my staging or if it is my dev environment, only then the toggles will actually work at runtime. There are other frameworks available that allow you to play with toggles in your your Spring Boot server and things like that. At runtime, you can switch on and switch off features and basically use that to test deploy code. Do you all understand what feature toggling is about? I understand that this was a very simplistic case, but I want to demonstrate the point. But feature toggles can be applied at any level. And if you want to learn more about it and want to read about how you can apply feature toggles, there's a whole blog on the ThoughtWorks website by Martin Fowler, and there are techniques that you can use by branch, by feature in your code, and stuff like that allow you to play with feature toggles. So try this out when you go back. Try to put in a feature toggle instead of actually going by the instinctive way of creating a new branch, and give that a go and see how it goes. Yeah.
How do you collaborate when you're supervising?
How do you collaborate if you're on the same branch? Just
You're talking about how the commits are actually seen on the GitHub. Is that what you're referring to? So that's a trade-off, right? So when you use feature branches, obviously your commit history is going to look a lot cleaner. You would complete your feature in that branch, you would squash all of it, and then you would merge it into your develop branch. So when you look at your commit history, it will look a lot cleaner. I don't deny that. But it comes with a big trade-off, and the trade-off is you're not continuously integrating. Right? Imagine situations such as you are you're providing a utility, you're implementing a utility function. Let's say you're expanding on a string utils class or something, and you're providing additional functionality in there. You want that utility function to reach your other peers as soon as possible, because otherwise they might be writing the same utils function for their code as well. Or they might not see it and they might implement it in another way. So in that way, you're just making your code become more spaghetti rather than, a very clean way, and you're integrating a lot faster. You're seeing other people's changes a lot sooner. If you had to deal with a merge conflict, you're made to deal with it a lot sooner rather than 3 days later, where you have 40 conflicts as opposed to, tomorrow, and you'll have to deal with just 3. That sort of thing. When you reach a merge conflict, it will point you to have a conversation with the person saying, hey, you're touching the same code that I'm working on. Are you sure you know what you're doing? Or we should probably collaborate and try to come up with an approach so that we can avoid that. Imagine having that conversation after you have finished implementing a feature 3 days from now. It's a lot easier to have it immediately, isn't it?
Rolling back would be a trade-off.
Rolling back would be a trade-off?
I think so, yeah.
In what way? You're saying reverting a commit?
So if you're on a single branch, right, you're going back to a feature, let's say a release where everything will go back to that. Then you have clear comments on your master, because I didn't the code item that you showed us that had every commit on the master branch is supposed to be a release.
Yes.
So that way, it's easier for me to check out that code, go through everything, and I know exactly what was in that deployment in that way. But if everything's on a single branch and people are working on different features, or much commit history that's not as clean, not serious. Is that a fail?
So the commit history is definitely something that you'll have to deal with. Okay, but there are ways of actually working through that. So whenever we make a commit into Git, we first put in a story number. So we put in the story number, we put a file, and then we say person's name and the commit message as such. So if you want to look at all of the commits that have been made for that particular story, then you just provide the commit number and you're good. Bitbucket and things like that will be able to link that commit based on the commit name and the story, and they'll be able to show you what are the commits for that and things like that. So there are ways to get around that by just building some tooling around it and around making sure that you're able to understand what exactly was deployed and things like that. This gives you enough information for you to make a hotfix, for example. You pushed into production, you tag what you pushed into production, and you just branch off that tag, and you can fix in your stuff, and then merge it back in master and then release again. We'll cover what kind of strategies you can use for deployment in a short while. Just hold on to that. Okay. Any other question? Yeah.
Discuss it a little later on, but doing this way, when we start working, the one we get to go forward is going forward, we don't want to do that. So you keep doing going forward. We do a hotfix, keep moving on, then go back. So first, each toggle is already there, you can and then on.
So you just toggle the feature off, push it in, and you're done. That's your debug. So what's next? So I'll quickly run through this because I think we covered this in the previous session as well. So the thing is, the whole point of TDD is to ensure that you write a test and it fails, and then you fix the test, and basically this cycle. So you write a test, you fix the broken test, and then you refactor. Then you write a test, see it failing, fix the test, and then you refactor. So writing the test before writing your actual code ensures that you have enough test coverage at the lowest level. Bhavi will be talking about the pyramid, and you understand a little more about what tests need to be written at what level and things like that. But writing a test before you actually write the code ensures that you have a test that covers the code that you're going to write. That's very important, because in order to be able to automate your deployment, you need to be able to say that that piece of code that I've written is tested in some shape or form. It's tested. You won't be able to do that. You won't be able to certify that you're delivering good quality software if you don't have a test for any line of code that you've written. Take that with a pinch of salt. Probably might not apply to all situations, but in most of the situations. Does make sense. For any questions around TDD, let's catch up after this, and I can talk to you all a little bit more about it. The other thing that you can use is pair programming. So pair programming allows you to develop good quality software. It's not followed in a lot of places because probably there's some amount of misunderstanding of what pair programming actually means. I won't spend too much time here, but the thing that really gets to me is if you want a new person who's coming into your project productive, the best way to do that is with pair programming. The new person who's coming in will have no idea about the code base, will have no idea what to do, where to get the code from, or anything. If they pair with another person, then knowledge is transferred. The other person's, inputs are taken into consideration on the very first day they become productive. And slowly, their understanding over the code base increases, and you're making them productive more and more. That's one of the best use cases for pair programming. Second is you're having your code reviewed every time you actually write the code side by side. You don't have to worry about code reviews and things that happening at a later point in time. It's happening while the code is written because you have another person who's looking over your shoulder and looking at what you're writing. Right? So that's pair programming. And before we actually move on, I want to talk a little bit about consumer-driven contracts. Right? So this is when you're working with developing services, and let's say in the microservices world at least, this really helps. So when you're working with services, right, you don't want to be dependent on just the services that you're consuming while you're actually working with it, because it's just going to slow you down. So let's say you build a service and then you deploy it and things like that. When you deploy it and your integration test is running, for example, you don't want that integration test to be hitting a live endpoint at that point in time, because the live endpoint that the producer is going to give you might be down at any point in time. It can go down for any number of reasons. They might be making their own deployment. They might be doing a whole bunch of things. And then your test is going to fail. And it will force you to go in and start debugging as to why it failed. More often than not, you find that, okay, the service was not up. So then what happens is you start relying lesser and lesser on that failing test because you just go rerun it. So if you find that test broken, you just ignore it in the future. So why that test in the first place, right? It's just a waste of time. So how do you do this? And a few other things that consumer-driven contracts will actually help you, and get to that in a minute. So let's say that you have a producer who's actually, producing APIs, and the whole purpose of that producer is for consumers to consume that API. That's the whole purpose of that producer, right? Now, how many times have you actually created APIs and put it out into production and wondered, who are my consumers? I intended for this consumer when I actually released it into production, but I know that I've had 2 or 3 other consumers added in at a later point in time once they realized that this great API was out there. And then sometime about, 5 or 6 months down the line, you find that your consumers have hit about 10 different APIs, and you have no idea. You could log it, but you don't know how it's actually being consumed. So what does that prevent you to do? It prevents you from changing that API. You'll be scared to actually change that API, put it into production, and it is just guesswork from that point on as to which consumer is going to play it. Right? So it becomes hard to actually iterate and start, delivering, quality software and all of that. So what do you do? So you have an API and you have consumers. You would create a pact between your consumer and your producer. Now, what is a pact? The sole purpose, like we're saying, of the producer is the number of consumers that are actually consuming that API, right? So your consumer is actually driving how you design your API in the end. That's the way I think you should be doing it. You should be releasing an endpoint and expecting your consumer to actually consume it, but rather ask your consumer, speak to them and say, will this format work for you? And they say yes or no. If they say yes, then that's fine. You can move on from there. But then they can say yes along with a packed file that they can give to you. Now that packed file is nothing but a JSON, and it says what endpoint they're going to hit and what is the expected data that they want from your API. That's all you need to put into your own test suite. Make sure that when you call your own endpoint, you are getting that same data that your consumer needs. That's what the packed file dictates. So they test on a stuffed version of your API in their development and all of that. And with the help of that, they're able to produce this packed file. And then they ship this packed file to you. You include this packed file in your source repo, and you test against that. So if you make a breaking API change, that packed file test would break, and it'll let you know, okay, I can't do this because my consumer is basically, it's going to break their API. So I'll have to talk to them. I'll have to keep my existing version, probably release a new version, and then slowly talk them into moving to my new version. So this is an automated way of doing that, and this is something that you can consider. There are implementations of pack in a whole variety of languages, and you can choose which one you want to actually use. Just read about them, it's very useful. That's step one, and that's step two. So where are we leading towards? So we're trying to move towards an automated deployment all the way up to production, right? And this is a typical deployment pipeline, and it starts with your team checking in code into repos, and your CI, it could be anything, Jenkins, GoCD, there's a whole bunch of CI tools available in the market. And your CI pulls the code from the repo and then runs a unit test at the very beginning. And if you see this yellow arrow is basically a feedback loop. So if your unit tests fail, you would be it'll notify you very quickly. And it happens at the feedback time that it takes for a broken unit test suite to you should be very, very quick in a matter of minutes, about 2 or 3 minutes, and you'll know that you've broken the code. And it's just a unit test that have failed, and you'll have to go and fix them. Next, you have an automation around regression. So this regression could be a whole bunch of things such as integration tests. You stand up your API on an environment, you call your API endpoint, make sure that the data that's coming back is fine. That's a sort of an integration test for your API endpoints. For your UI, you want to look at putting in functional tests and things like that. Again, Bobby will talk about this more when she's talking about testing strategies. So this is automated regression. And then you have deployments into staging where manual exploratory testing can be done. At the same time, you can invest in a performance testing suite, which is your NFR. And then, if everything's fine, you deploy that into production. After production, you would have monitoring and you have alerts and things like that. And all of that is basically building onto that feedback loop that gets to your team. So that's basically a build monitor. And it's one that's in the top office in the total office. Almost every team has a monitor such as that. The idea is if the build is broken, it should be very visible, and the entire team's sole purpose becomes to fix that build. So you start talking about having a social contract. And the contract could be something like this. You fix the broken build on priority. You stop what you're doing. So if you are the person responsible for that broken build, you stop what you're doing, and your priority now becomes to fix that build. Because on a broken build, I don't want to push my change in, because I have no idea whether I'm breaking the build, if it breaks again, or was it broken already. So I'm going to stop from checking in any code, and I'm going to wait for you to fix the build. And I don't have indefinite patience. So I'm going to say that I'm going to wait for about 10 minutes. And if you can't fix the build in 10 minutes, I think you should revert it from it and push it in. So that it unblocks me to push my changes in. So that's the kind of social contract you need to talk amongst yourself and agree. And the last line reads really well with me, you're doing continuous delivery when the team prioritizes keeping the software deployed over working on new features. So I'm going to leave you all with that and hand it over to Bobby. And she was going to talk about testing strategies and things like that. But think about this and ensure that if you've got a build that's broken, you prioritize fixing that build first.
Before we move on, does anybody have any questions on whatever said before? So we can move on. So now you have all your development done and you've nicely done TDD. So what is the next thing that you do, right? So the entire crux of continuous delivery and continuous integration is, so your software is as good as your tests are, basically, because that gives you more confidence in your software. So what we're going to do here is we're going to go through some testing strategies that will help you do continuous delivery, and it will make continuous integration more helpful. So if you're doing continuous integration, whatever Setu mentioned, you're committing your code every day or every few hours, it is not of any use if there are no tests which are running which validate your code, right? You can do only a certain amount of manual testing. You can't, it's human tendency, right? You will probably forget to test something, or your older features will break and stuff like that. So you're really doing continuous integration only if you have good testing strategies and you have a lot of automated tests. Okay, so this is what essentially happens when you do late integrations, right? Let's say you mentioned about continuous integration. So this is essentially what you have in mind when you start off in the project, and this is when you integrate at the end. So one pair is probably building the legs, one pair is probably building the head, and they just don't fit together, right? So this is a very classic consequence of late integrations into your main software. So how do you avoid such a thing? You avoid such a thing by truly practicing continuous integration, and the most important part there is devising your testing strategy, right? So what you see on the left here is what we generally see in most software, and what is very tempting to implement also. We have a very small bunch of unit tests. We have a bigger bunch of integration tests because that sort of gives us more coverage. And we have a lot of automated GUI tests because they're easy to validate. Because you can just look, oh, okay, click, and it's happening, it's working. And there is like a big bunch of manual tests which is left to the QAs or the testers in your team, right? So these manual tests essentially include a lot of your regression suites where you have an Excel sheet of a lot of steps and you just check all your features which were old and new just to see if the new features have broken your old features. So this is sort of an anti-pattern. So what you see on the right is something that we think would help you a lot, and with our experience, we really think it helps. So in this pattern, what you want to do is you want to have a lot of automated unit tests, right? There are a couple of reasons for that. The first one being they're very easy to write, especially when you're doing TDD. You've almost always written tests to actually check your business logic, which is on your service layer or on your service side, right? They're really fast to run because ideally in a unit test, you would not connect to your external services, your databases, or whatever else you're consuming, right? So it actually purely tests your business logic. After that, you would have equally important, but fewer maybe integration tests, API tests, or component tests, which test your interaction with all the other components across your software or application. And after that, what you have is fewer automated UI tests, right? So why this pyramid? So as you go up this pyramid, your tests become much slower because a UI test would technically involve spinning up a browser, the page loads, you log in, you click, and you do a lot of actions, right? Also, they tend to be a lot more brittle. Okay. There can be implementations which are less brittle, but they're generally very fragile. In the sense, you probably added one component in your UI and changed an ID of the other component, and suddenly your tests are breaking, right? So it's a false positive. So your code has not changed, it's not buggy, but your tests have failed. So you will just spend a lot of time fixing these UI tests. So ideally what you want to do is have a fewer set of acceptance tests which are very high value user functionality, like flows that the users value a lot or use a lot or do on a day-to-day basis. And then you have your integration test, right? So your ideally your UI should not have a lot of logic. And even if it does, you have a lot of testing libraries like Jasmine and stuff to test your UI for JavaScript, Jasmine. And most of your logic would come from your API. So just doing an integration test on your API should help you there, right? And obviously you will have to do manual testing because you can't automate everything. Plus there is a lot of exploratory testing that your QAs would do, your testers would do, or you yourself would do just to explore the application to find out what the users would be doing. So manual testing cannot be gotten rid of, but what it can help you do is spend more time on the higher value activities, right? Yeah. Sure.
So can you elaborate on what are the underlying assumptions in this slide? Because I've heard you talk about so there are application architectures that treat business logic at a higher level, and then there are also architectures that treat them at a layer level. Number two, we are talking about automated component tests. So that means we're speaking about a component level architecture or something of that sort. So how would this extend to a level-driven architecture or something different than a component level architecture?
So this pyramid is very representative. What I mean to say is your unit tests, which are actually testing a business logic, should be covering a major part of your testing pipeline or your testing cycle. Why the UI tests are at the top is because they are very expensive to write, expensive to maintain, and they take a lot of time to run, which makes your feedback cycle a lot slower. So what happens is once you start running these tests, it will probably take you 10 or 15 minutes to figure out, okay, that something is broken. But if you have most of it covered in a UI test, you already know that some logic is wrong somewhere or something is broken somewhere. And do you have anything to add?
No, and component and integration test means that if you're looking at API to API communication, consumer-driven contracts is something that I spoke about. It's very, very useful. It runs at unit test level and it runs very quickly. So you want to cover, so the idea is to get feedback faster and with very little effort.
So the metric you're tracking is just the time to get feedback. And
the value of what that test is.
So
we'll talk about it more often.
There is sort of a trade-off between how much effort it takes to write that test and maintain that test, as opposed to the value that the test is actually providing you in your entire feedback cycle or in your entire development and delivery cycle. Right? I hope that answered your question. So how do you achieve that? You've already spoken of it. You do automation, you automate as many tests as you can, ideally most of them. And what are the benefits of doing that? Like I already mentioned, fail fast, right? You really fail fast, you know that your logic is broken in probably 2 or 3 minutes if your unit tests are running. You get very effective feedback because you're testing one thing at a time. So once you're running your integration test, you don't know what is broken in that entire cycle. Right? When you're running your unit test or something like that, you know, okay, this is the component that is broken. Or if you're working on a feature and you're testing that feature while working on it, you know that it's that feature which is broken. It's easier to find and remove bugs because again, you have faster feedback and you're testing per feature or per story. And you have higher confidence in your builds because you have a very well-defined testing strategy which covers most of your code, ideally all of your code. As the build progresses through your testing pipeline, you have higher and higher confidence in your build because you've tested it at every level. Apart from helping the devs, it also helps the QAs in the sense that they don't have to do a lot of repetitive regression tests, which is just mundane and monotonous. What they can do instead is spend their time in higher value activities. Like doing more exploratory tests, which would again feed back to your automated regression suite. And also what happens is some of your tests might require a lot of elaborate setup. Like for example, you have some ETL running which feeds data into your application. And that ETL job takes a lot of time to run, plus you have to edit data, change configurations, and so on. So something like this would take a lot of time for somebody to do. You can just simply automate this and put it in your pipeline to test all the possible scenarios that you can do. So how do you do this? What are the major techniques or tips or tricks to do that? The first thing is you have to choose what to automate. Like I mentioned, you can't automate everything. One very effective thing that we've observed is you can pair the QAs and the devs to write or design your test suites. Maybe set up a test framework in the beginning where you can you mentioned, if you have some external services or you're consuming an API from somewhere, you can set up the server can set up a fake container which you can access, or you could hit some other APIs to check, like some mock APIs. So you can design your testing framework beforehand with the devs. Follow the invest principle to design stories. What I would like to point out here is, so invest is independent. So your stories, as in chunks of work or small features, should be independent, negotiable, valuable, estimatable, small, and testable. Right? So what is really important here is that these stories are small because you can continuously integrate them well, and they're testable and independent. So testable means that entire thing can be tested in one shot. So instead of breaking your stories and say you have a UI story and a server-side story, you have to manage. The server will have to expose some mock API for the UI to consume and test and build. Instead, you can have vertical slices of your stories. They're fairly independent. So a story includes doing the UI, the front end, the back end, database, everything. And it makes the entire thing testable and valuable also. So committing that one thing gives you visible value. Make tests faster, parallelize them. Like we mentioned, we're going to have a lot of tests in our pipeline, right? We have unit tests, integration tests, UI tests. So it makes the feedback cycle a lot faster if they run in parallel. Like for example, if one test took 2 minutes to run, another took 5 minutes to run. Suppose the first test broke, right? You would fix it, then you would run everything. Then 2 plus 5, 7 minutes. Oh, the second test also broke, so now you have 7 minutes. So you already have spent 9 minutes where you could have spent 5 minutes, right? Because both the tests ran in parallel and you saw that both needed to be fixed, and it just makes your feedback a lot faster, basically. And in today, where we have containerized deployments and stuff, and we have the cloud infrastructure very handy, it can be quite easy to parallelize your tests. Right? You can have multiple agents run multiple tests, or multiple machines run multiple tests in parallel. So the next thing is test crucial non-functional requirements. Like Setu already mentioned, if you have any business crucial NFRs, like for example, you need your API to return a response in 2 seconds because your consumer requires that. You can, even if the API gives a correct response, you can just fail that test at that point if it exceeds 2 seconds. And so this is the simplest example of an NFR. You could do much more sophisticated tests for your to test how much load your APIs or application can take and so on. So next you would ask, what if I have a legacy system which is already there in place? How do I start with the testing strategy? What do I do? Right? So what you can do is start by writing tests for the code that you're changing. It's very simple, right? So now when you're adding new code, you start by writing tests for that code, and then you can keep on incrementally adding tests. So probably when you add an integration test, you can add a few more tests and then an integration test on top of that, and so on. It might be difficult to convince people in your team or outside why you need a test for code that's already in production and already working all right. It's because you can, with confidence, say that the new feature that you've added is not breaking any older features that were already in production or any older things, right? And it all just fits in very well. So this is a very crucial part of continuous integration.
I have one thing actually I want to talk about the question about what sort of architecture does it cater to, right? Yeah, I just had a thought about, a comment maybe on what sort of architecture does it cater to, right? A unit test is like at a unit level. Typically, to give you an example, if you were to, if you ever felt a UI test is the way to go, what would happen is you write code, you design code, spend over coding, spend a couple of days, write code, get it out. Then write a unit test, UI test, then runs, and then realize that something has gone wrong, right? Typically, but if you started with say PDD and a unit test, you get that feedback even when you compile or run the test in your machine. So that helps you design. You probably see what to inject, what to be injected into the code, or what needs to be right then and there, rather than put the entire cycle. So I don't know if I don't know if say PDD helps you say. Has been an architecture in a big way, but at a unit level, you're getting feedback on your design every day. It eventually leads to your architecture of sorts.
Also, one more important thing that I forgot to mention is a practice that we follow. Is that before we even check in code, it is very important that you run your tests locally also. So I have seen that happen where you just push code and then you leave it up to your pipeline to run your tests, and then you see that the tests have failed, and then again you have to make a commit. So one of the good practices is to run tests locally, which means your infrastructure has to be like, it has to allow you to do that. Right? You have to be able to run at least your unit tests locally to see if your logic is fine and can be checked in. And also, before you check in, it's something that we call DevBox testing or shoulder check, which is before you push in code, you might want to call in a QA or a BA to have a look at the functionality that you've developed, to play around to see if the basic sanity of that functionality or the acceptance criteria of that functionality is being met even before you finally push the feature, or you, in that case, turn off the feature toggle to make sure that the feature is now available. So the next thing is deployment. Now that you have all your development done and your testing, the one thing that makes most of us nervous is deploying into production. Right? Even though you have your code ready and deployable right now, it is often months before you deploy to production. Right? So how do you change that practice? How do you make your code more deployable? Because like you mentioned, the crux of continuous delivery is to make sure that your software is always deployable. That is why your team's priority always is to keep a green build over writing new features and so on. So ideally, it should be that you leave up to the business when they want to do the deployment. Your software is always deployable. If it hurts, do it more often. I really like this quote. So it happens a lot of times that because we don't like deployments and if there is a high rate of failure, we don't do it. We do it once in 3 months or 4 months. But we should do it more often so that we get better and better at it, and we find ways to automate it. We find ways to make it easier and to elevate our pain. So how do we enable continuous delivery? One important thing is to maintain everything in source repositories. Everything. Whatever your build requires, whatever you need to build your software should be checked in. Your configurations, not your secrets. You could probably use another secret management or encrypt them or some other strategy to manage your secrets. But apart from that, everything that you need to build your software should be checked in. Basically, I should just take my machine, probably clone the code and run a command and have my software up and running. Automate deployments. Why this helps is when we are doing continuous integration, we essentially have a lot of environments, right? We will have a development environment, a DevBox, where we want to run tests locally. we will have a staging or a QA environment, we will have production environment, and we need to continuously deploy to these environments to run our integration tests, our functional tests. So that's why it's essential to automate deployments, because it makes it really easy to deploy to these environments. And once we are confident that we can deploy to these environments, deploying to production should be equally easy, because your entire deployment is essentially in one script. Make builds self-testable, reproducible, build quality into your software. Basically, it should not be that you check in your binaries because I don't know if this thing is going to build to the same binary again. That's not a very good way of having code, right? Self-testable, I mean, have your unit tests and your integration tests and all the tests that you have as a part of your repository. Treat them as your source code itself. Keep them clean, maintainable. Test in a clone of the production environment. By clone, I mean same operating system, same version of softwares, exactly same. And that you can do if we have this automate deployments part. And why that is important is because you could be testing in your dev box and maybe in your staging, and it works because it's a different software, different version of some tool than what is in production. So we don't want that to happen. We don't want to discover bugs after we go into production, especially after we.
Just one example that I want to give here. This happened to me in a project, and and it was very bizarre in the way it actually happened. So we had some code in production, and it was behaving in a way that we didn't anticipate. So we looked into the source code repo, and we found that there is no way that this code could run in that fashion in production. There's absolutely no way. So then, to prove the point, we basically downloaded the code from production logs, we decompiled it, and we compared it with what was in the source code repo, and it didn't match up. And then we started investigating and finding out exactly what code is running there. And we found that somebody had compiled it locally, put in a hotfix, and just pushed it off into production, and that's it. So we basically had no idea, that was what we could, after investigating, and that was the only reasonable conclusion. That's what has happened. So it becomes very hard to actually do this, right? So that's why we say it has to be reproducible, the code has to be reproducible, everything has to be checked with the source code reports, and then it becomes, highly important. Every time you get that code, it will work the exact same way.
Along the same lines, deploy the same way to all environments. Again, this is enabled by automating your deployments and by making your builds reproducible. Immutable deployments, by that, I mean, once your code is into a staging environment or production environment, you don't log into that environment and change some configurations. No, you can't do that. So what you would do is you would probably bring down your entire cluster or whatever, change whatever needs to be changed, and then bring it up again. So that, again, when you do it, you don't have to go and change the configuration. Because what happens is, oh, I had to update this software today, and then after 10 days, you forgot what you did. When you deploy again to production, again, it's not working. So we don't want to do something like that. One more way of ensuring, along the same lines, immutable deployments is having your entire infrastructure as code and checked into your source repository. So by infrastructure as code, I mean, for example, using Dockerized containers or using Dockers, having your Docker files and Docker Compose files checked into your source repository and stuff like that. So what that helps you with is you can bring up the same environment in your local box and test your code there, and then push it to your QA and push it to your staging and push it to your production. So that way, all your configurations are tracked. It's not like some magic happened in production and now you don't know what happened, right? So infrastructure as code. And every build is a candidate for production deployment, which is essentially make sure that your software is always deployable and treated in that fashion. What you also can do is, once you have your software in production or in any environment, you can have a bunch of smoke tests as a part of your deployment itself. Just to do a sanity, just maybe curl the URL and see if it is coming up, maybe just do a login to see if it's coming up. Simple test just to see if your deployment went through all right and fine.
Sorry about it, just one second. Yeah. Are you all okay to continue? We've been running on for about an hour. Do you want to take a break and we can come back? Or, yeah? Is that okay with you? Let's take a break 5 minutes and then we'll come back. We've got a lot of content to cover. So 5 minutes, please.
Okay. So we just have a couple of things left with deployment. After that, we can go ahead. So going on, another thing that we mentioned and that we generally want to do is have painless deployments with, downtimes are what really make us nervous about deployments, because that is the time that the user cannot access the application and you have to just fix things in 2 hours, and that's what contributes a big amount of that nervousness. So what we ideally want to do is try to have zero downtime deployments, right? So we'll discuss a couple of strategies of doing that. So one of them is blue-green deployments. The way this works is you have, for one environment, say for example production, you have the same set of servers, like your entire infrastructure cloned. Okay, so you have a green infrastructure, which is the one that is currently being used actively by the users on your production or whichever environment you talk about. And you have another one, which is a blue environment. So what you would do is when you want to deploy, you bring up this blue environment, you deploy to that environment, and you can do all your, you can bring it up, you can see if everything is all right. You can probably just use some demo user to log in, see everything is fine. And then you can just switch that router to use the blue environment. And now blue has your latest release and green has the one older version of deployment. So why this really helps is that it's very safe. You just have to switch that router, and the rollback strategy is simple. Again, switch the router. And you can do this, you can keep the other environment up for some time until you have the confidence, and then you can just bring that environment down or keep it as you please. This is obviously not as simple as it sounds, because there could be complications, like you have databases. Most of us have a database backend that we talk to. There are sessions that are active in an environment. There are transactions that are going on. How do you handle those things? So for example, you could use a separate session store like Redis or some key value store to manage your sessions such that they're external and still remain active once you switch. For databases, you could probably use the same database, or you can do a backup and restore. That would take time. It would not be instantaneous. But again, it's not something that can't be done, and you have to devise a strategy based on what your infrastructure looks like and what your web application looks like. So that's blue-green deployments. Any questions? Another strategy which is getting popular these days is canary deployments. So the word canary deployments comes from the old term where miners used to send canaries out into mines to see if everything is okay. If the canaries died, they would see a risk and not go. So that is where the term canary deployments comes from. So in this, what you do is you would have two versions of your API. One is the current existing stable version that your live users are using. And the second version is the new one that you have deployed. And what you would have is you would have a router conditionally switch users between these two versions. So you could do these switches based on multiple things. Maybe you deployed to one geography the new version. So in that case, you would just send all your users to this bunch of servers and otherwise to another. A lot of people release software first to the internal employees and then back to users. Or you can just do it on a percentage. Like only 5% of the requests go to this and the rest go to your current version in production. So what this helps you do is, apart from testing your application and the new version in a live production environment, it is sort of like A/B testing, where you have a bunch of beta users and it just goes there and you can see what's happening. Also, what it helps you do is, rollback is very easy because you just have to not switch and redirect everybody to the older version. And it also helps you test your capacity. So you can slowly keep on increasing the number of users which go to the new environment. And if things break, you can go back, or you can add some resources or do something to help the capacity, right? So yeah, and then eventually you would just switch all the users to a new version and then go on again. So you can do this to see how a feature is received, etc. You can do this over a period of time. Another popular approach is rolling deployments, where if you have a bunch of servers serving your API, you bring one down and bring one up, and you keep on doing that, and within a couple of minutes or maybe sometime, you have all the servers which are serving the new API version now. So these are some strategies that you could use to have zero downtime deployments with lesser risk, and yeah, so that's about deployment.
Yeah.
How is this European deployment and Canadian deployment is different?
How is it? So European deployment is basically so when you have something that's already serving live traffic, you're standing up a whole new infrastructure stack, and you have that in isolation, and it's not serving production traffic. Your production traffic is still being routed to your old stack that is stood up. You test this in isolation. You certify that things are fine. Your product owner has a look at it. Everything's fine. So then you switch your production traffic in its entirety to the new stack that you've stood up, and you demolish your old stack. It just goes down. You don't need it. You can keep it for a while, but once it's proven and everything's fine, you don't need that hanging around. So you get rid of it. Next time, you stand up a whole new stack, and then you do the whole thing again. So the important difference here is you switch all of the users in their entirety to the new stack. Canary is both your stacks are serving production traffic at the same time. The only difference is the new stack that you've stood up serves a smaller amount of traffic to a select set of users that you want to try or something. That's it.
So in Canary deployments, you can simultaneously have two versions of your API being served to live users. So again, there are a couple of things that you need to keep in mind, that your API has to, you have to make sure that whatever you're serving, like your UI has to well receive both of them, both the APIs have to be handled, and so on. But
make sure, so these things will only work when you look at how your new version of your code is going to be backward compatible. So your DB changes have to be backward compatible. The changes to your service has to be backward compatible. You can avoid a lot of pain if you're able to factor this in your design while you're working on this. Your rollbacks and your roll forwards, all of that will be a lot easier if they're backward compatible. If they're not, if they're making changes, you need to look at how to go about doing it in zero downtime. There are strategies of doing that as well. We can talk about that. Okay. So this is the first point in the Agile Manifesto, right? Which reads individuals and interactions over processes and tools. So what that means is, in any software development world, you put people as the number one priority. So you deal with interactions. So what sort of things that you can do, what sort of mindset you need to allow continuous delivery to be a success in your organization? So you need to start with the people, right? And you need to look at your team makeup. You can't have the DevOps team sitting in complete isolation to your development team, and your QA team is a separate team that's sitting in isolation to your development team. They all should be working as one integrated team. So an ideal team makeup would be you'll have developers, you'll have QAs, you'll have a BA, probably have a UX person, you'll have a Scrum Master or a project manager who's working alongside that team, and that team size would be typically between 8 to 10 people, and it comprises of everybody, and everybody owns testing, everybody owns deployment, and everybody is looking at, okay, the build is broken, what do we need to do? So that responsibility is shared, and you don't say, okay, my job is to just develop and push, and then there's a whole other thing that's going to look at building it and deploying it. It doesn't work like that. Next, you have technical architects that are far removed from the day-to-day work that developers do. They sit in isolation, and they kind of come up with these requirements that developers in their day-to-day life, while they're coding, need to work on. They release new stacks, they release new ideas, they have brilliant ideas, some of them. And because they're not working alongside developers, they're not able to contribute and they're not able to feel the pains of what developers are actually feeling. So they need to be able to sit with the team, work with them, and developers along with technical architects need to take the vision forward for that company. Only then every developer would know what the vision is. Every person in the team would know what the long-term vision is for this architecture, and they'll be empowered to make medium-term decisions over short-term fixes, which is just going to work presently, but fail down the line. Next, you need to look at cross-functional teams. So you have organizations where there are lots of services, and if you have to go and find out about a particular service, you're asked to go to speak to this particular person, and he kind of becomes the SME around that service, right? And then if it's another service, you'll have to go to another person. So they work in silos, and sometimes there are teams around these people, and they help, making enhancements and delivering changes on that service. Sometimes what happens is one particular team is bombarded with requests for changes, and they just will not be able to deliver, right? And no other team can help them because nobody knows what they're doing. So we've seen organizations that realized this, and they started changing the way they actually do things. So they built this sort of a pod of 5, 6 people, or 8, about 10 people. It's a complete pod, like I was saying earlier, with devs, QAs, and DevOps, and all of them in one pod. And they shift between one service to another service. And slowly but steadily, everybody knows every service, and they'll become cross-functional, and they'll be able to take on any service. And that's an investment that the company has to take. Otherwise, it's a single failure point. If that person who's actually leading that team leaves, then you won't have anybody who's empowered to make decisions around that service. So that's cross-functional teams. Last one is visibility, right? So you need to know what each person, each team is actually doing. Your product owner needs to know when is a particular feature going to hit production. Where is it in that deployment pipeline? That's sort of a visibility you need to build. You need to input that into your deployment pipeline so that anybody can look at a particular commit, will see what story that was and where it is in that pipeline, and be able to make a decision as to whether that makes sense to be released right away or not. That sort of visibility has to be built in to any tooling that you use. It also means that if there is this team that's building this great API or this great UI, they need to be able to pass on that knowledge to every other team so that every other team can leverage what these people have done rather than reinvent the wheel. So you need to have regular showcases, you need to have regular meetups within your company and try to share the knowledge across. So this is where we thought we'd take a break, but we'll quickly move on. Okay, so the second part is basically talking about realizing all of this into an actual CI tool that we built. It's a tool called GoCD, and ThoughtWorks maintains it. It's an open source tool. You can download it and use it for free. And we'll give you an example of how we've actually done a very simple UI and API setup, and how it actually works. So before we go into what it is that we're going to show you, let me talk to you all about a little bit about AWS architectures and how it's moving and what our build pipeline essentially does. So this is the traditional. That's my point. Okay, so this is the traditional setup, right? And this is something that was presented by an AWS architect in a conference, and it is a very simplistic architecture. But he did make a good point that about 80% of all of the web applications out there follow this architecture. It's a very complete architecture because you have static HTML, JavaScript files that are placed on S3, and it's just a file store, but it also acts as a web server. You can make it serve your HTTP requests, and you can get your HTML and JavaScript files right out of here. It's extremely cheap, and if it's put in behind a CloudFront, it becomes extremely fast with any user anywhere. And so that's basically, so this is, how the world is moving towards single-page applications where you have HTML and JavaScript files compiled separately, and your backend APIs are placed separately. So that's your front end. It lives here. And from your front end, it would actually hit a load balancer, and it would hit all of these EC2 instances that are running behind this load balancer. And notice how they're actually placed on different availability zones in order to allow disaster recovery. And basically build resilience, and in case any one particular data center goes down, they still have the other data center serving live traffic. And again, that sort of redundancy is built on the database side as well. So you have a master and slave, and there is cross-AZ replication. So if you have this sort of an architecture, you can probably go live with it, and you can serve any amount of load with it. Because it's a part of an auto-scaling group, so if there is any, if there's a lot of load, this will basically just spawn out new servers. So that is traditional. A lot of people still use the same methodology. Now they probably would have Dockerized this and started using an orchestration platform rather than raw EC2 instances. But there is a whole new way of actually build things, and that's with lambdas and functional as service. How many of you have heard of lambdas? I've worked with it. Nice. Okay. So again, your front end is still the same, but then your back end has now been replaced with lambdas. And lambdas give you this amazing ability of not having to pay for a continuously running server. It'll only be kicked off, and it'll only be started up when it receives a request from the front end. And it can run only for about 5 minutes at tops, and it works very well for some use cases, not so much for others. But for a typical web application, which needs to read some data from a database and serve it up, this sort of an architecture actually makes quite a lot of sense. And it is really cheap. You get infinite scaling, and for zero amount of code that you have done. All of that auto scaling and things like that doesn't happen automatically. You need to configure it. You need to look at parameters that you need to auto scale with. But with lambdas, you get all that free, because every instance, every call triggers a whole new lambda. It doesn't, if there's a lambda that's running, it doesn't wait for that to finish. It triggers a whole new lambda, and it executes on that. So today, our deployment pipeline is basically going to try doing this. So we have 2 repos. One is a UI repo, and there's a backend repo. And the backend is basically just Lambda functions, which actually get deployed. There's no database. It's a very simplistic calculator app. And that's the infrastructure for our GoCD. It's running on my Mac currently. The GoCD basically is a combination of a server and an agent. You need to have both in order for it to work. You can have as many number of agents as you want. You want to spawn as a number of agents, as many number of agents as you need, because it gives you parallelism in your builds. Every build will just execute in its own agent, and it will be a lot quicker. So the server is the one that basically orchestrates and sends the jobs to the nodes to basically execute. So that's the configuration right now. I've got these 2 running on Docker. The server is running on Alpine Linux. This is running on a Debian, and I basically just configured this to ensure that it runs node and serverless and a few other things. And this is running on my Mac completely, not inside Docker, and this is where the functional tests are run. Oops. Up to the monitor. You can talk. You go ahead. Thanks,
Okay. So what we have here is a value stream map of our entire CD setup, CI and CD setup. So value stream map typically shows you your entire, gives you a holistic view of your entire CI. Your entire continuous delivery pipeline. So this is a value stream map for functional tests. So we have two SCM sources, like two source code management sources, like Setu mentioned. One is for the front end, the web app, and one is for the backend service that we have. So the way this flows is, so for the functional test, the upstream is the input from the source code management system and the unit test, and the downstream is the deployment steps, right? So when I say upstream, what I mean by it is whatever is going to trigger the functional test. And when I say downstream, I mean a successful run of the functional test is going to trigger these things, right? So whenever you check into either your web app or the service, it's going to trigger the unit test for the web app and the test service. It's sort of the commit build. And after that, it's going to trigger the functional test just to make sure that nothing is breaking and there are no compatibility issues between what is triggered. So if you see, so it's going to, every check-in triggers this, and a successful run of the unit test will trigger the functional test. So if any of these steps fail, the pipeline stops immediately. And a successful run of the functional test will trigger deployment of the service as well as the web app. And a successful deployment to the development will trigger staging, and not directly production. We have a manual step in between for production, where, and staging also, we have manual steps where you can say, okay, approve, and it goes on to the manual step.
So the idea is you have a UI function suite, and if that is successful, then you can make an immediate deployment into development. And the point to note is, every command that you actually push into your Git repo will result in a deployment into the development environment. There is no wait, there is no guesswork. You know that if you commit and if you see the build running, the next point in time, that code is going to be sitting in your development environment. So this is very easy, right? Because you've automated it up to that level, and you can just log into your development box now and just play with your code and see how it's working. And once you're actually satisfied, you can let your QA know that, hey, it's passed through all of these steps in the pipeline. I can guarantee that I've done my job to the extent that I can. Now it's your job. Why don't you pull in the build, and you can pull in this build, and this is the story that I've actually implemented. Now why don't you give it a shot and see if you can break it, or if you can find anything that I need to fix. If the QA breaks it, then the cycle repeats again, and we start pushing it. If the QA doesn't break it, you get manual exploratory testing. Then they can say that this is signed off, and the next step is to basically showcase that to the product owner or to whoever is interested, all of those stakeholders. And if they say it's okay, then all they have to do is click a button and it will go into production.
So if I show you the staging, yeah. So this is what the deployment to staging looks like. This is a manual step here where it waits, and the moment I click this, it will go and deploy to staging. So that's what he meant when he said that once the developer gives an okay, you can ask the QA to deploy to their environment. They can do their testing, and then if you look at the production, again, so you have two builds ready for production which have passed the staging, and you can just click and choose whichever you want to go to staging. You can also hover over, you can also see what are the changes which triggered these builds, and you can decide which one goes ahead.
So this sort of a pipeline concept is very native to GoCD, and you can see your entire value stream in this beautiful sort of a UI. And once you actually push in something into either repo, you would actually see that things light up here and they change from green to yellow. And you can see your value streaming through the pipeline. That's what we're calling the value streamer. So we wanted to actually walk you through, how this works, and just like how we structured the entire agenda, we wanted to take you through this in the very same fashion. So the first thing that you actually see here, the Git repo, and the first step where you're actually unit testing it, that's your development phase, and that's how you actually, when you're pushing code and you're pushing into your Git repo, you have your unit test running. and you get first feedback saying whether it's broken or not, right? And the next part of that is basically your testing strategies where you have your functional tests. And the way the functional tests are written is it helps you catch issues such as if I push a breaking API change, how do I know that my UI is compatible with it? And that's your gate right there. So it'll not work. So we'll just show them that and get into that demo. I don't think we have time for the gate folks.
Okay.
Okay.
Before we go ahead, we have a build monitor setup like we showcased in the presentation. Okay, so this is a build monitor. We're using something called memory. We set it up locally, and what it does is it points to our Go CD, and every time there's a build running or failed, you will see.
Right. So these are my web repos as such. So I have a service and I have a web application, and I have also a repo for Go CD. And what's inside the Go CD repo?
Oh, not audible.
What's inside the Go CD repo is basically a description of what the pipeline should look like and any configuration specific to the Go CD infra itself, such as the Docker files that help bring up the Go CD infrastructure itself. That's inside the Go CD. And just like how we were saying, put everything inside source control. So we're putting the source, the sources for, the configuration for your source repo. Sorry, what am I saying? The configuration for your Go CD inside source repos as well. So it's reproducible. You just have to clone your repo and you can bring up your Go CD infra.
So
yeah, go on.
I'm just saying this is a classic example of your infrastructure that helps you develop as code, which is checked in again into a source structure.
So before we move on, let us show you what we've done. Right? So it's a basic calculator app, and instead of calculating the result of an addition or a subtraction on the UI, we intelligently send the two numbers back to the Lambda, which is going to sum it up or minus it and return it back. That's what we've done. So that's what it does. And so this is built on React, the front end, and the back end is your Lambda, which accepts two numbers and does stuff. Okay, so how do we break this? So let's go to our service, and the service is basically so we have a subtract, we have a multiply, and we have an add. So I just want to break something. So instead of expecting the query string parameters as number 1 and number 2, let me just change that to operand 1. And operand 2. And in order to make sure that this works, I've got a test as well. So I need to fix the test. I know that it's going to break. So my test is in the integration here. And in my multiply, I can't call this number 1 anymore. I have to call it operand 1. I'm calling it operand 2. So this is now ready to go. And we're just trying to show you how the build fails and how it actually looks when the build is when the build doesn't work. Okay, so it's just one file, one actual file, and there is a test that's being changed alongside it. Yeah.
So ideally, what you want to do at this stage is, can you increase the font size? Yeah. So we've just submitted the change, breaking of change, and then we've committed it. So we should be able to see a build trigger. So ideally, what you want to do before you push is, keeping in mind the testing strategies that we had, we would add a pre-push hook, which would at least run your unit tests, and it would not allow you to push if the unit tests fail. So we wanted to demo that, but we did not have time. So it's as simple as just for JavaScript, just doing installing some npm package, Husky in our case, and just adding pre-push hook in the package JSON, and that would just run a test before you push.
It takes time, so we can talk about other stuff while this is actually happening. So there it is, and that's the build monitor that actually picks it up as well. So if there is something that is running, then it actually comes up as yellow, and we know that it's actually building something. And this looks very nice when you actually put it up on a hanging television screen, and it's very visible across the floor. So I've had cases where we work in tables just like that. So there's one team that sits here, there's another team that sits close by, and both of them have build monitors. They're two separate teams, but then they egg each other on if in case the build is broken. They come over tap for a hey. So it's not just you, it's basically you're displaying to the entire world and trying to get it done. It's not showing.
Oh, sorry.
Right, so while this is actually building, and we can see that, let's move on to, so it's now picked up the functional tests, and the functional tests will eventually break. So while that's actually happening, let me just walk you all through what exactly happens in the deployment phase, and how are we actually deploying things. So on the web application side, you want to check in how you're building, how you're deploying that knowledge along with your source code repo. It stays very close to your source, and it's very easy to maintain in that fashion. So along with my web app, I also have a folder that's called Infra CloudFormation. We're using a CloudFormation template that all it does is it'll create an S3 bucket, and it'll make that S3 bucket, set it up in a way that you can publicly host HTML and JavaScript files. And the template looks like this. I'm hoping you all can see this. If you all can't, it's nothing nothing much. All it is I'm creating a bucket, and the bucket is created based on the region name, where it's dev, staging, or prod. And I'm setting up the bucket such that it's a website by itself, and the file that it has to hit is index.html. And I'm setting up the policies such that all of the files inside that bucket are publicly accessible. And that's all that it is. And once the S3 bucket is done, we also have a deployment script that goes along with it. So this part of the script basically creates, executes that CloudFormation template on AWS. It creates the bucket and basically runs the CloudFormation template, so to speak. And once that template executes, the next line is basically deploying all of your build files into that S3 bucket. You just remove your old files, and then you redeploy your files that you're locally building, and that's what is actually getting deployed. So that is this. Now let's take a look at how the functional tests are actually running. So that's basically the functional test running, and it's broken. That's not refreshed yet. There it is. So it tells you very quickly by just looking at the logs, you'll understand. I've broken the multiply API, and it's basically not returning back what I need. And you'll go in and investigate, and this will prompt you, and it'll tell you that your check-in has pushed in an API that is incompatible with the UI, and you'll have to go in and fix it. So while I'm fixing it, you can talk about stuff.
So what we saw this script that we are looking at right now is exactly an example of how you would use the exact same script to deploy to every environment, right? So there you just have to pass a stage parameter, and it automatically puts it in the bucket name and puts it in your API gateway name, and you can use the same script to deploy to all the environments. This makes sure that all your environments are same, and if it's tested in one of the environments, you have a very high confidence that it will work in the next environment that you're going to deploy to, right?
Yeah.
It's fixed?
It's fixed, it's pushed.
Wow.
There's nothing
So-
wow about that.
We should see a running test.
Okay. So while that happens, let me just walk you all through the pipeline as such and what actually happens in every stage and how it's being configured to run. GoCD has this way of configuring the pipeline as code. So going back to the philosophy of making sure every bit of your configuration is in source control, that fits into that. So that entire pipeline that you saw, that entire value stream map that we drew, is code that's checked into your source repo. So you have your web application, which we'll take a look at first. Your web application, the first phase is a unit test phase, and the materials for that phase is basically a Git repo. And it has a stage which basically is testing it, and the script that you run in order to test it is a yarn install and a yarn run test coverage, which is basically just build, it'll install all your dependencies, and then it'll just run your npm test. After this, we have functional tests as a separate file because it's actually shared between your service and your web application. So your functional test is here, and the function test has a whole bunch of materials that are going in. The first two materials are basically a dependency on the pipeline. The pipeline that it's actually depending on is the unit test web application pipeline and the stages test. So after the unit test of the web application is done, we want a functional test to trigger. We also want a functional test to trigger if the service is getting built and the integration test of the service stage is basically getting built. So these are our pipeline dependencies. We have a whole bunch of other dependencies as well because we just don't need the pipeline. We also need the source repos in order to get the web app code. We need to get the service code. We also need to get a functional test code. We need to stand up a local HTTP server where we can serve our web application files. We need to stand up our API server as well, so that the web application and the API can talk to each other in a local environment. And then we need a functional test, which will basically bring up the browser, pointing to that locally running UI and run unit UI tests on it. Does that make sense? Any questions here? So once that is done, then I have a script on my function test that basically runs the function test, and it does exactly what I just said. It brings up the UI, brings up your services, and runs your function test on it. And then moving on to the deployments part, where you have your deployment, and the deployment is basically depending on your functional test now. That's your upstream dependency, your pipeline. Once it finishes your functional test, we then need to also depend on the unit test upstream because we want the functional test and the unit test to feed into the deployment, and we need the source repo again. So then we need to build our, we're going to deploy to the development environment, so we need to build our UI for that. We need to, so UI is a different beast, right? The thing is, you can't have properties and you can't, change at runtime where the URL has to point to for your backend API and things like that. The only option is you have to rebuild your UI with the, with your backend API URL coded in it. So, so you need to build it. So, any questions there? I think I'm losing you guys. A lot of you are falling asleep. We finished some. So, so that's the build for deployment, where we first need to build, and then we need to deploy. And deployment, again, is just via scripts. And the only thing that changes between the deployment to the development environment and the staging environment is just these parameters, your development key and your staging key. Apart from that, you'll see, if I go down, you'll see that it's exactly the same. So you have a deploy script, which passes in the development environment. If I go down, you'll see the staging deployment script, which is exactly the same. In fact, you can abstract this into a whole script itself by itself, and you wouldn't have to repeat this. And the production deployment is also exactly the same. So that's what we mean. You deploy in the exact same way in every environment, and you make sure that things are fine. So the build is back up again.
And it is triggered both the development deploy builds, both the builds to the development environment. So the only thing that's different, like you mentioned, is the access keys, and they are configured within the pipeline as parameters that for each pipeline they're configured as parameters. So they're essentially things that can be extracted out as templates, exactly same, only with different parameters.
Right, so I think that's 10 minutes after 8, and I think we've run out of time. That's all we had actually. Was there, we're ready to take questions now, and if any feel like getting late, I think dinner might also be served there by this time, hopefully. So, any questions here? Anything that we can help?
We talked about the use of knowledge. So what usually happens is, so when something like project has a lot of features going on, the different people are working on different features. So we introduce one feature audit for each feature, and there'll be a lot of feature audits in our code. So what that means is, after some time, when we want to like enable this feature for good, we had to clean up all these feature audits one after the other. So this maintenance trade-off, is it something that we have to accept, or is there any other way?
That's a good point. You need to come back and clean up. There's no other way about it. If you don't clean up, then you just static code that's not everywhere, and yeah, you'll have to come back and clean up. And sometimes you would also, if it's a smallish kind of a story, you might not even need it. You might be able to just get it done that way. So I would say use feature toggles for stories that take a few days to complete, and you definitely don't want to risk the state of the system, compromising the system by introducing a half-baked story. So you want to put a feature toggle in there, and after that story is deployed into production, you want to come back and keep it.
Or if it helps, just put a tag like card saying, the moment this is done, I have to pick this clean up, or the last comment should be the one.
I think there was a very good question in the last topic. You were discussing exactly that, and there was also the one key point is to remove them. And what we did was, in our story wall, we had after done, we had another line blank for actually removing them. So we made sure that whenever we were implementing any tutorial, we had a point in time, defined point in time where we would remove that.
That's a nice idea. Any other questions?
Something kind of related to this. So I know companies or projects which go live like even in one day it goes live like 2 times. So there are like even I've heard of Amazon going live like minutes and all this. So how do they actually manage this kind of stuff? So I'm just curious.
Yeah. So what you're talking about is continuous deployment in production.
Yeah.
Right. And there's a stark difference between continuous deployment into production and continuous delivery. So with continuous delivery, you have the capability of choosing what you want to deploy into production at what time. So that control stays with you. With continuous deployment, you lose that control, and every commit that you actually make into the system goes straight through production. Now, that might work for some companies, that might not work for other companies. It depends on the amount you are willing to invest in a process like that. So, you need to strengthen, so just like how we started off the presentation, right? Your deployment, testing, and your development practices has to be fine-tuned to that extent that there is no chance that an accidental incorrect commit would make its way to production. So you would have fine-tuned all of your stages. You would have introduced that level of testing in your automation to ensure that something like this never happens. And it makes sense for some companies because they are ready to invest that amount of time and people into maintaining such a thing. It doesn't make sense for other companies because they're there to deliver value to the customers, not to fine-tune their deployment pipeline. So again, it depends.
So how do you handle security
So with security, do you mean secrets that are secret? No, you mean security, actual security. Yeah. So if every environment is identical, then you can actually get security testing done a lot easier. You can get penetration testing done a lot easier. So in this client that we were actually working, they were willing to do, so they engage external penetration testers to validate that it's fine. And they were willing to actually get penetration testers working on lower environment than production. And that they could do with some amount of certainty that it's going to be exactly the same as production. So if there's any issue that they're able to find on a lower environment, they're fine with actually using it in production. That helps, right? So if you have identical environments with its own set of firewalls and things that are also identical, then you know that if they test on a lower environment, it's so you, again, it's feedback earlier in the game.
Is that automated?
No. So with security testing, some amount of it can be automated, right? So static code analysis tools can be used. Some amount of automation can be put there, but predominantly a lot of penetration testing happens by people deliberately trying to break it up, and that can't be automated beyond some.
So, your suggestion was that to unify all these streams to enable CA instead of having multiple branches. So, what would organizations who are already using such technology? It would be very hard for an existing pipeline.
So it is going to cause a disruption. That's for sure. But as a company, as an organization, as a team, we all need to understand what benefit it gives and whether it actually makes sense to switch. And you would start with a small team, with a small isolated team to prove that this is possible, and then slowly, use that team as an exemplar team and get everybody in around that team, trying to understand how they work and how they're able to push their stuff faster, how they're able to develop quality code, and how they're not struggling to do all of this at the same time. Use that team as an exemplar team and get more people in on the action. And slowly but steadily, you find that it actually spreads throughout the organization and it brings about change. You don't start with a company-wide change. It's not possible. You start small and then go big.
I assume that you have adopted the same model here, which is earlier branch-based, like you said.
Yes. So we've been called in by a lot of clients who have used Git flow and branching techniques, and that's why I was saying that's a real-life example, basically, from working for a client in Cloudworks. And sometimes it is very difficult convincing a client, and we might not be empowered in such a way to actually go in and help because we've been called in. We are a consulting company, right? So we called in to help, build sometimes just a small part of a bigger puzzle, and that's all the extent of the contract is. But if we are empowered and we can actually go in and bring about that change, we have brought in the change in exactly the same fashion that I described. We start off by going in as an exemplar team. We get 3 or 4 developers from the client working alongside us, and we kind of pass on what we do with them on board, and then we bring in more people, and then we move from one kind of a pod to another kind of pod, and kind of spread that knowledge across. That's the only way to do it. So you can do it in your company too by getting your your team to start working on it, convincing them that this makes sense. Let's try it, and once you've proven it, then you can actually start expanding that and get more people around.
In this model, we still have to forget the advantage of having branches. Is it possible going forward they can have automatic merging branches themselves?
So the problem is not branching. Branching is never the problem. Git allows you to branch like that. The problem is integrating after your branching. And that cannot be solved by an automated fashion. It cannot be solved in any fashion. And that's why we are saying don't branch. Have a single master branch which is always deployable, and you maintain that state by using feature problems. So there is no guesswork saying, okay, for this I will branch, this I might not branch. You just don't branch, and You use feature toggles to govern what's in and what's off. It takes some amount of So it takes some amount of trial and error to actually come and understand how to use it. But once you understand how to use it, then it's fine. It just sits right in the head, and you can just keep working with it.
I just like to also point out that when you start, it will be very difficult. So visibility also helps. Like Aiko gave an example about adding a new lane at the end after you're done, when you're to remove feature toggles. You have to make a conscious effort to do these things. Like maybe having a story wall, we have that common practice where we actually put up the story cards. And so if a story is not moved for 2 days, you have to probably see what has happened. And at that point, it's probably very difficult to merge it back if you're using a branching strategy. So I think visibility and a conscious effort that you really want to do this helps.
You had something to say, Aiko?
Okay. So from my experience, feature toggle is not a cool thing to want to have. Feature toggle can be painful, but it is less painful than the work you get when you have multiple branches. It's not the perfect way, but it's the best way we have, I guess.
It's not a silver bullet. That's what you say. There is no silver bullet. I think whenever we've done this, right? I've done this a few times, and the point that people actually get stuck upon is feature toggles and branches. And there's always been a very lively discussion about should to branch or not to branch. And so, it's a battle that you can't win sometimes. It's a battle that you can try and win sometimes. So I would say so. This was very difficult for me to understand as well. When I initially started, I didn't understand it. So if my product owner comes in and tells me to do this today, I can do it easily if we follow the git flow technique, because I know that the master branch is pristine, sacrosanct. Only the good things get checked into the master branch, and all of my features and all of my in progress work is not even touching the master branch, so it's easier, right? But then when you look at it from the other angles of how you're integrating, how your code becomes spaghetti and more spaghetti because you're not integrating early, and how it actually affects you to be able to deliver faster. And all of those things, when you look at it, it slowly starts to sink in. Yes, okay, maybe I should try feature toggling next time. And that's how I tried. That's how I started, and started using feature toggles a lot more. And now it is just second nature. So you just need to give it, just take a plunge and see how you go. And if you have questions, we can always ask around and get that help.
I would just like to bring up one instance of this, and where we had a discussion on this. So we were also looking for a branching model. So we were also looking to go in with the flow or with the countries. My question initially was how to say, for example, our requirement was something like that. We never had in a single our common rollouts. So for example, for one region, we have rollouts of one step advanced than other regions. So we had to do this was the question at that time.
Feature toggles. So you're talking about you have one region that's actually deploying something.
So,
yeah.
Say for example, for one market already you mentioned advanced, and the other markets are planning to roll out down in 2 months or so. And then right now, both are in production, and you have to keep supporting both of them.
Yeah, so I would release to all markets at the same time the same code. And I will feature toggle off what markets I don't want it to be. That's it. And then I know with a certain amount of certainty that every deployment that I'm making, every place is running the exact same piece of code. For this very specific reason, you should use feature toggles, because you would find it very hard to debug your own app in the future. So if you have about 5 separate versions of your app living, and each of them is actually being taken out from a separate branch, very soon you'll find, okay, that's diverged so much, I cannot use it as a separate branch even. I'm going to fork the repo and start a whole new repo. and then you find that they actually start going separate. So at that point, it might make sense for it to actually live separate lives and die separate lives. But then, until that point, you want to keep everything together. If you don't want to keep it together, then take it off into a separate source so that it has its own life cycle. But otherwise, deploy everywhere to the same code and then fix the problem.
You guys mentioned about one good point, using the infrastructure as a source. That's a really good idea. How do we handle differently that idea when our applications are distributed in nature? Because I see it to be working great for standalone applications, be it web app or mobile app, it works great. But when we have our applications which are distributed in nature, for example, Kafka, Hadoop, the distributed nature applications, containerizing them is a tedious task. So, what are the best practices?
So you can bring up a Kafka cluster, Ansys cluster, and all of that using CloudFormation.
When they are on cloud, it's easier. But when
there are other ways of doing it. So if you're not using the cloud, then you use Ansible and Puppet and Chef. There are a whole bunch of these orchestration tools that you can use. So the thing is, if you use Ansible, you can check in all of your playbooks, and all of them are, checked into your source code repo. And you just have to get it, you just run one command and you basically deploy everything in a very predictable manner. You can stand up anything nowadays with scripts. If you don't have a ready script, you can, whatever you're doing manually, you can automate that, right? If you're running shell commands to actually stand up something, just put that into a shell script. That's how you start, and then you slowly start, building on top of it, and completely change your infrastructure deployment into an automated script that runs. It is possible.
And so I have one more something related to that. So in case of the standalone applications, right, when we are completely it's like one Docker instance which is running already. It's like we're going to bring it down, and the new Docker instance will just make it up and running. So what would happen to the persistence part? Because when we are dockerizing everything,
persistence in terms of session storage or persistence
in terms of the latency.
You want to answer this?
There are concepts of volumes in Dockers where you can mount whichever drive you want as volumes, and you can also persist the volumes itself, which are created separately, and you can still go ahead and bring up new services in your Docker.
Did you talk about database persistence in the end? Yeah, okay. So with databases, are you talking about Docker containers running databases, or are you talking about
Docker containers running databases?
Yeah, so then you just use the same volumes, right? So the volumes are not going to get destroyed. So make sure that whatever you need persisted. So if you're deploying a whole new version of, let's say, an Oracle database, then
how about the sessions which are running? You mentioned about the strategy like using Redis to
the existing sessions that are running on the database is very hard. I'm not sure. If I was an AWS, I would just leave that to AWS. I use a managed RDS instance specifically for that reason, because I don't need to worry about upgrading my databases, making sure that nothing happens to my existing customers and stuff. If you have to really do this and manage this on your own, then you have to do what AWS does. You'll have to build up a whole new Docker instance, and somehow at the point when there are no more connections to that database, switch over to your next one, and then you're free to do what you want to do. So if you're finding that hard to do, I would just use a managed service like RDS.
So when I mentioned sessions, I actually meant user sessions or application sessions, not database connections.
My next question was on that too, because that's also very hard in the user sessions which are live.
So all of the services should be stateless. That's the way you actually work, and that's the easiest way you can scale. If you build session storages within the services, you cannot scale. You want to use Redis to actually, or key value stores that you can use and retrieve stuff. So don't use sessions. Sessions are, I don't know, it's a very old way of doing things. People now have started moving away from sessions that are located within the heap of a running instance, and offloading that onto specific clusters that can actually manage session storage. All you need is a key to retrieve.
You're talking something related to the command segregation model, where everything is just a command. It is not like doing a session.
So command query segregation is more about designing how your services work. I'm not talking about that. I'm talking about building stateless services. So if let's say the user is logging in and you're creating a session and you're dumping things about user preferences and what the user is doing on that session, you cannot bring that server down until that user logs out, right? So you need to offload that out and make your service stateless and keep everything that you're collecting on that session within the heap that's running, on that instance, and offload it onto Redis or Memcache or something like that. And use a key, a session ID to actually retrieve when a new request comes in, rather than just hitting a session.
Makes sense.
So what we can do is dinner. Is dinner there?
Oh, yeah,
There is plenty of food. So what we can do is get some food, and if there are any questions, we can answer them individually. If you want to head back out there, there's some refreshments there. Not dinner, but some sort of refreshment.